The training today again is server-side rendering in Docker, and our agenda is as such. And just a side note, we are doing server-side rendering, headless server-side rendering in Docker, but this implementation will also work just on a Linux machine with an NVIDIA card to render headless without any kind of virtual frame buffer or anything like that as well. So just a side note. So we're gonna start with a quick review of the different streaming mechanisms in Hoops Communicator. I think most of you are probably familiar, but I'm not sure who was going to join, so just a little bit of context there. We're going to kind of do a quick review and talk about what server-side rendering looks like on just a standard standard server, standard hardware, not virtualized or not any kind of container technology. We'll talk a tiny bit about the constraints in the standard Docker environment, and then we'll have an overview of the NVIDIA Container Toolkit, an overview of EGL, just so you know what it is and what we're using to accomplish what we're doing, what you're going to see today. Then we're going to do a quick demo and set up server-side rendering in Docker, and you'll see it run. Then we'll just kind of next steps where you can go from here, where you can get some help, and then questions. So just to review, Hoops Communicator really works in 3 ways. There's a way you can load files with no streaming server, and that just loads files over HTTP, and it loads them asynchronously. And so your user would request a file, that file would be downloaded basically like you would download an image or any other resource on the web. And while that was happening, the user wouldn't see anything. Maybe you'd put a spinner up or something. Versus our streaming mechanisms, which are interactive. So the user starts the session and they start to see things come into the viewer immediately. And this can be the triangulation, or it can be images from server-side rendering. The way that's achieved is you convert your CAD file, or other data using our authoring libraries into our streaming cache file format, which is spatially organized, and it has random access. We also, will bake things into the file like measurement data and other kinds of data if you've specified those options during conversion time. And then we've got 2 types of streaming here. So we've got when you're talking about the streaming mechanism and not loading asynchronously, we've got client-side rendering, which is the client makes a WebSocket connection to the server, and then the data is the triangulation, the tessellation, and data from the file is streamed down to the viewer and then loaded in a WebGL viewer. Or we have server-side rendering where the file is loaded on the server and images are generated and those are streamed down to the viewer. And so we're going to be talking and focusing on server-side rendering today. And I'll just give you a quick demo of what the 2 types of streaming look like and how you can tell what's going on. So throughout the exercises today, I'm going to be using our quick start folder. So if you're not familiar with that, the way that works is this is the package. If you were to unzip Communicator package on your machine, you'd see this quick start folder. And inside of here, we kind of set some things up for you. There's a basic configuration, there's a temporary license, etc. And we also provide a web server for you. And so I'm going to be running this quick start server just to utilize the built-in web server. And what you're going to see right now is I'm going to go ahead and run that. And so we've got the server running here, and then I've loaded this file back here, which is the index file inside of that folder. And what that does is just present you some models that you can look at here. And so we'll go ahead and look at the same file. So we'll start with client-side rendering here, and we'll load that in the viewer. And so this model is being loaded down and rendered in, and you can see kind of what it looks like when we rotate it and things like that. If we go back and we do the same thing and we use the server-side rendering, we'll see it looks slightly different. You'll see you have that fuzzy image as we're moving. These are the slightly lower quality images, and then if we stop, boom, the high quality image gets snapped in. And so that's kind of like a telltale way if you're looking at the Communicator viewer to understand, like, oh, am I doing server-side rendering or client-side rendering? It's really hard to tell unless you're used to using the server a lot, but that is the difference there. And the thing that's nice about Communicator is our JavaScript API is the same regardless of which streaming you're using, or even if you're using the non-streaming version of Communicator. So you write your code to our API, and you can dynamically switch between viewer types, or streaming types rather. And so this is nice for if you want to dynamically determine what type of device a user's on, or maybe do some kind of quick test to see if they have a high bandwidth connection, and then make a decision whether you want to go to server-side rendering or client-side rendering. And then just, because with server-side rendering, you can target low-power devices, things that don't have a GPU, stuff like that. So that may not be the only reason you use server-side rendering, but it's kind of one of the nice things to have. So that's the different types of rendering. Also, you'll see the SCS loading. That is the serverless loading, the asynchronous loading I talked about. And we call it SCS. It's just a different type of stream cache file. It's completely self-contained. And so that's why that's referred to as SCS. So we'll come back here. Let me see if I can get back to where I was. Yep. Okay. So now what does server-side rendering look like traditionally? And traditionally in the web is a weird word anyways, because that changes probably weekly. But what that means here for us is that the client makes a WebSocket connection to a running server. So I get a stream cache server on one of your web servers somewhere, and then the user, when the user requests the model, it's loaded in the stream cache server. And the key here is that images are generated on the server using a GPU. So we're using hardware. And so a lot of web services and stuff, they're web applications, they're mostly, CPU based traditionally. And because of that, they can be hardware agnostic, and they fit well into a Docker container. We have had ways to do this without a GPU. We've done, you can try to do software rendering. You can use like a virtual frame buffer to do the off-screen window rendering, but we only have ever recommended that for development purposes. It's not stable for production. And so we used to have some instructions. We may still have some instructions in our documentation to set headless servers up without a GPU, but it's, again, not a production ready solution. So those images are then streamed down. But the key thing that we're trying to get across here is that you usually need some kind of access to the GPU if you want to do real high quality server side rendering. And so what this has meant in the past is that you have to pay for an upgraded, if you say you're using Amazon Web Services or Google, you have to pay more for GPU enabled servers. And so you'd like to get more bang for your buck there. And that's kind of where Docker comes in. So Docker, if you're not super familiar with it, it's a container technology. You create an image, a base image of your application and all of its required libraries and such. And then from that image, you can instantiate runtime containers. And those containers they start up very quickly and they shut down quickly. And generally the idea is that container pops up, does one thing, and leaves. And what's nice about them, other than the fact that they load up quickly and shut down quickly, and they have all their required libraries and such, is that they're portable. So you should be able to run this container on, you should be able to instantiate this image on any container service. And that makes it nice for deploying applications. So Communicator, we have had support for Docker for some time. And people have been using it for client-side rendering and also for our authoring tools. People have been doing that for a long time now. But what we haven't had good support for, or any support for, prior to Hoops Communicator 2020 is doing server-side rendering in Docker. And this is kind of by design for Docker, because as I mentioned earlier, web applications and Docker applications are meant to be hardware agnostic and generally GPU based. And because of that, there is no direct access to underlying hardware, because you might not have that hardware available to you in the environment that you're running on. So to make that work, we need two things, and that is the NVIDIA Container Toolkit. And so this toolkit, NVIDIA has been around, I want to say 2016 or something. At least that's when I first started hearing about it and using it. At that time, it was, and I think, and maybe even a bit before that, it was primarily used for in the compute environment. And so, like these applications that are compute intensive, they use the GPU as well. And so there was a need to be able to access GPUs from these Docker containers. Obviously, there's a little bit of a downside here in that you do take away some of the portability of your application, because it has to run in an environment where you've got the NVIDIA Container Toolkit and you've got an NVIDIA card on the host and you've got a certain driver requirement on that host. But if portability is not necessarily what you're going for, but you're going for scalability, and you kind of going to be working in a known environment, like on your cloud service provider, like defines this hardware and what you're using, then the portability aspect of it may not be such a big deal for you. And I think a lot of our partners are actually aiming for scalability over portability. And so what happened was we saw this technology, we had some requests for it, and we started to do some research on it. And then we went ahead and looked at the NVIDIA Container Toolkit, which does provide you access to the GPUs, all of them, via your Docker containers. It is Linux only. And as I mentioned earlier, it does require the NVIDIA driver to be installed on the host, an NVIDIA graphics card with NVIDIA drivers. So, and the reason I specify that is you may be running on a Linux environment and you're using the open source drivers, but you need to have the proprietary drivers installed for this to work. And for us, we require driver version 430 or above, and that is specified in our documentation. The second thing that you need to make this work is EGL. And so this isn't something you need to worry about or you need to install, but this is something that we had to add to Communicator. So when we're doing the rendering prior to this, we're just using standard OpenGL and rendering to an off-screen window buffer. But now we have implemented EGL inside of Hoops Communicator. And so this allows you to have an OpenGL context without needing an X server or a virtual frame buffer or anything like that. No UI.
Hey, Rob, let me stop you just really briefly. Andres asked if you could elaborate on what EGL is.
Yeah, so it's the native platform graphics interface. I will link to it at the end here so you can read more about it. But what it basically is it's an implementation of OpenGL that can render in without needing any kind of UI. No, you don't need like traditionally you'd need an X server or something, which would allow you to create a window to render into. EGL does that all in memory without having to install any kind of X server or any kind of virtual frame buffer. So if you were to render on a headless Linux server right now with an OpenGL application, you'd likely get an error saying there's no context to render into, meaning that there's no window to actually pop up and render your graphics in. Even an off-screen window is the same thing, it's just not showing up. EGL allows you to render in using traditional OpenGL, but without having to have that that actual extra layer installed on the machine. So no X server installed on that on your server in the cloud, or no virtual frame buffer has been kind of another hack that's been around. Not really a hack, it's been around for a long time, but it's another way to do rendering. And the virtual frame buffer kind of, I think, presents, and I don't know all the details of how that technology works, but presents a context which makes OpenGL think that it's rendering into a window somewhere. And
got it.
I will tell you that I don't know, I'm not an expert with EGL or anything like that. I just know it's the technology from the Kronos group that we use and we've implemented so that we can render in without the need of an X server or anything like that.
Great. Thanks for the question, Andres, and thanks for coming up.
And so the main reason I'm talking about this is to let you know that you don't need to have an X server or a virtual frame buffer going forward with hoops to render server-side rendering with Hoops Communicator 2020. And what's nice about this is kind of a point that's beside the whole Docker discussion, meaning that this is useful for even if you're just using a Linux server right now, you're not using any kind of container service, you're actually using a Linux server in AWS or something with a GPU, and you've got an X server installed, or you've got a virtual frame buffer or something like that, or even in your development environment, you can now do server-side rendering on that. Like, in fact, on my Linux machine, I switched over to using this when we enabled it. And for this, this is an EGL requirement. The NVIDIA driver supports EGL from version 355 or greater. So, just so you know, a lot of this stuff is very dependent on the version of your driver, and these things are listed in our documentation, and this is specifically listed in the EGL documentation, which you as a developer don't necessarily need to worry too much about. You just need to know when you're using this, there's a flag that you're going to use when you're instantiating the Hoops, the streaming cache server, that says -EGL yes. And so you're going to wonder what's EGL, and this is kind of what this is, and that's why I'm giving you a bit of background on this. So let's jump into it here. Let me come back here. So yeah, as I clicked on that link earlier, you'll find inside of our Communicator documentation, we have a little subsection in the programming guide that's Docker support, and it kind of goes over pretty much everything I'm going to talk about and a lot more. And so I will link to you at the end. There will be links to this again, but I just want you to know that this does exist in our documentation. So,
hey, Rob, before you get started on that, we had a question kind of following up. Is there no equivalent for AMD cards yet, which can be used to get Hoops running?
Not that I know of. And so the crux of this problem is the NVIDIA Container Toolkit. So it allows us to have access. Well, EGL. So EGL there's likely an implementation on other graphics cards. You'll have to check your graphics card whether it supports EGL or not. If it supports EGL, you can do this off-screen, or you can do this server-side rendering on a headless server, as long as you've got a graphics card that supports EGL. So that portion of it, yes. I don't want to speak more than that because I'm not an expert on it and I haven't done research, but I believe that there is a support for EGL on a number of graphics cards. So that's that answer. Now, the Docker portion of it, not that I know of, there's no other way to do server-side rendering in Docker, because as far as I know, there's no other graphics card manufacturers or anything that have created this layer in Docker that allows you to access the hardware. Okay, so before we get started here, I want to go over the different files that I've provided. So if you're following along here, I have these files open here. Let's start with the Docker file. So the Docker file we provided here for this training is just basically the one that's in our documentation. And all we're doing here is we're taking a base image from NVIDIA, which these base images NVIDIA hosts on Docker Hub. And so there's different types of base images that they provide. Using the Container Toolkit, you can do different things, like, you can say you just want to do compute and you're not interested in doing rendering, or you're not interested in doing video or any of the other options that they allow you to use via the driver. You can use just different base images. And so what we're doing here is you're seeing I'm grabbing the NVIDIA OpenGL base image, and then I'm going to create my own image from that. And so all I'm doing with that is, setting a label here. I'm saying that I want to be able to use all the GPUs here. This NVIDIA visible devices means I want to be able to use all available GPUs. You could specify a number, 0, 1, 2, however many you have. You can specify all or none. So if this were, for whatever reason, you didn't want this image to have access to them, you can do that as well. And then I'm specifying driver capabilities here. I kind of mentioned this earlier, but some of the options here are compute, video, rendering. There's different things. These are all in the documentation for the NVIDIA Toolkit, which I have put a link to at the end of this slideshow. The other thing I'm doing here is I'm setting up the environment paths, setting up some things inside the Docker image. So, the path to setting the LD library path, so where we can find the streaming server binaries. I'm opening up a port here, 55555, just because I'm going to need to access that port from outside the Docker. So I'm doing that, and then I'm creating a few directories, and I'm copying the binaries over into the image, and then along with this entry point shell script, which we'll look at, and then our hoops license, which again we're going to look at in just a second. Okay, so that's that file. So that's the main file we're going to run here in a second. We'll run a build command to build our image, and then when the way we've built this is saying that when this container starts up, we're going to run this entry point file here. And so that means is we're going to start up the streaming server. We're going to specify that we're going to do SSR, and also that we want to do this SSR EGL. And so that's kind of the flag I was talking about earlier. And then we want this streaming server to listen on this port, and that's the port that we opened when we built the image. So when this container starts up, it will have that port. Likely in a production environment, you would specify that port like as one of the commands to the container when you started it up. You wouldn't build that into the image. We're just doing that for simplicity's sake here. Because in a production environment, you're likely going to spin up a number of these, and then you're going to need different ports to listen on. And so that's just a note about that. And then we're telling it where to get the files from on the container. And we'll talk a bit more about that in a second, where the log file is, our workspace directory, so it can find all the files, and then the license file, which we're going to provide to the container. And then, we've provided to the image, which will be available on the container when it runs. And then this last thing is just passing in any other options that were passed into the Docker run command when we started the container. We're going to pass those in. So the reason we did that is it allows you to have a look at the options for running the streaming server, and maybe you want to pass in some different options at runtime to your container. And so you can pass those in at the Docker run command, and they will be appended to this shell script. Okay, and then the other kind of main file for this exercise is this really small HTML file I created. So this HTML file, all it does is it starts up the viewer, and then it's going to connect to the listening Docker container. And the Docker container is going to start up on 172.1.7. And if you use Docker, this is a standard IP that they start up their first container on. So in the real world, you would run a Docker command to get the IP of or you'd have it, spit out the IP or something like that to a file, or some other way you'd get the IP of the container. You might use the container service you're using, which would provide it to you, and then you would connect to it. And again, you'll see we're going to connect on that port that we opened up, and we're going to load this micro engine file, and we're going to do rendering, server-side rendering here. So that's just setting the type of rendering we're going to do for this session. And then the last file I provided you is just an easy to use. It's just a little shell script to save the run command, so we don't have to type it every time. And what we're doing here is we're going to run the Docker. We're going to specify all the GPUs available. We're mapping the port from the host to the container. So that way, if I'm on my host here and I try to connect to it on 555, it's going to pass it through to this container. And then what I'm doing here is I'm binding a few directories here. So I'm going to bind the current directory plus quick start and the converted model file. So as you'll see here in a second, we're going to drop these files into the quick start. So I'm just so that way I don't have to copy all the files into the container. I'm just mapping the directory where the files live on the host to where where we specified the files will live on the container. And then here is the image name that we want to instantiate. And so we'll see that in a second, how that gets created. And then last, I'm just giving it an ID for this for this running container. The file that I didn't provide everybody, if you are following along, is this hoops license. So let me drag that. I should just drag that into here. So this hoops license file, all this is create a file called hoops_license.h. And what you can do is grab your temporary license key from the quick start. If you come into your install where the quick start folder is, you'll see this server config. If we drop that, if we take that into our text editor, and then we come to the bottom here, you'll see that there's a license string. Just copy that license string without the quotes and drop that into a text file and rename it to hoopslicense.h. That's all you need to do there, and put that next to here. So this temporary license is delivered with Communicator. I think it lasts like 60 days or something, maybe 30 days. But when you download a new package, our quick start will run out of the box with this temporary license. And you can use that for, testing out different things, kind of like what we're doing here. Okay, so once you've done that, we're gonna grab all of the files except the streaming file. So the license, run, Docker file, and the entry point, and copy them into the base of your install. So this is the root of the install for your Hoops Communicator. So if you unzip the package, you'd see this, and we're going to drop these in here. And then what we're going to do is we're going to open up the quick start, and we're going to copy the connectToStremer file in there. Okay, next step here. So this is where it gets a little. This is where I'm going to start. I'm going to start typing some commands. I'm going to drop these in the chat for you. So the first thing we're going to do is we need to build the Docker image. So I'm running this command here. This is in our documentation, by the way. Let me find the chat here. Here you go. So this is the command I'm about to run now. Oh, I see that. How does the license work if you want to spin up a 10, 100,000? So we're baking the license into the image. So that's why that license needs to be available. And the way our license work, it doesn't call off to, we don't call out to servers or anything like that. Our binaries just check the license file when they run. So what that means is once you create the base image with your license in it, it means you can instantiate as many as you want, 10, 100, or 1,000. Does that make sense? Just make sure. Okay, great. So I'm just about to run this Docker command here, this build command. Let's go ahead and run it, and you'll see I'm building the Docker. I'm going to build the Docker image here, and this should just take a second. Okay, you see it's doing everything we did in the file there. It's running, it's copying things over. Now we have an image, and you see it's tagged with this TS3D Communicator SSR, and that's because that's what I gave the name. That's what I tagged it as when I created it. So if we run Docker image ls, you'll see we now have this new image here, which means we can start creating containers with that. So hopefully everybody's got that. So before we move forward running this, there is a command. You should have installed the NVIDIA Toolkit on your server or in your container service or wherever. You should have the right drivers installed, and then you're going to run a command to test it. And so let me find that. Okay, so this command I'm about to run here is a command that's listed in the container service. Let's go back to chat. So this command is from NVIDIA's documentation on how to test your environment. So I run it, and when you run that, what it's doing is just running a Docker that it pulls down from Docker Hub, and it's going to run and test and dump out some output. It's telling me here's all. If you see a table like this, you're good. If you don't, you see an error or something like that, it means something's not set up with your container service or your NVIDIA container service. Otherwise, if you see an output like this in your driver version and NVIDIA SMI, you're good. So that's just testing our system very quickly. I already know mine works, right? Because I've been doing this for a long time, but I just wanted to mention that. in case you're having problems. We'll likely ask you to run this command first to make sure that you are set up correctly. Okay, so now what have we done here? We've built the image, and we've dropped a file into our quick start server over here, right? And then what I have in this other terminal is I've run the quick start. So inside of the quick start, if you open up a terminal, there's a file called start server. And if you run that, that runs our built-in web server and gets you set up so that you can play with our setup out of the box. Everything is self-contained. The streaming cache server, all that jazz is running on this local machine. But I'm only, again, using that to leverage the web server. So let's go ahead and run our Docker container here. And as I mentioned earlier, I created that run file for you. So if we run .sh, okay, so that's good. So what you're seeing here is not super exciting. It is exciting if you know what's going on. What we're doing is we're running a container, an instance of that image that we just created that has access to GPUs, and it's running the streaming cache server, and it's waiting for a connection. And then you saw it just timed out. So the way that our streaming server works by default is it times out, I think, after 15 seconds. You can change that behavior. You can specify different options. But what that means is that you can spin up a Docker container, and you have, at this point, we have 15 seconds to try to connect to it before it goes away. So let's run that again. And then I'll come back here, and I'm going to come to this local, if I can type, localhost connectToStremer. And so what you saw now is you're seeing a bunch of output. So this is great. I connected to the running Docker here, and it's saying it initialized the EGL library, and you're seeing a bunch of output from NVIDIA. You're seeing my card and all that. And then we loaded the data. And so this is great. Like we are now running, we're running server-side rendering in a Docker container. And prior to Hoops Communicator 2020, this wasn't possible. So this is great. And if you, I don't know if it's hard to tell over Zoom, I'm sure, but you can see you're getting that same behavior as you get the fuzzy image, and then when I stop, you get the clear image, right? And so now what's good is the Docker container will not, it's going to stay here. It'll stay around as long as I'm connected to it and doing things. But as soon as if I refresh and disconnect, the Docker container goes away, which is great. So now the cleanup's done, right? I mean, this is pretty cool, I think, for people that I just like the idea that I can spin up these containers, both server-side and client-side rendering, and connect to them. They wait around and they clean themselves up, whether I connect to them or not. I think is pretty cool. And so, so that's kind of the main thing I'm trying to show you here today. And I didn't have to install any kind of X server or frame buffer or anything that. And with inside of my Docker container, I'm getting high performance graphics, which is pretty neat. I just want to do one last thing before we're done with this demo here. And that is, if we come back to here. So, a lot of people ask me why it has a black background. Our server-side rendering by default has a black background. It's and so if you want a white background like most people do, you should set this callback, and when the scene is ready, we'll change the background color to white. I changed that background to white. Let's restart the container here. So I'm going to run the container again. And then I'll refresh this page, which will make me connect to it. And then obviously not do as I intended, because you know why? I edited the wrong file. Let's copy that file over. So I edited this file. Let's copy it over to here. Replace the one that's replaced. Okay. Now let's start our container again. And then let's do this again. And there you go, white background now. Just because I get asked that question a lot when people are doing server-side rendering, so I figured I'd toss that into the training here. So that's about what I have here. Let's come back here, and I want to give everyone a few more minutes at the end to ask questions. So I'll close out. So what you saw here is something that's pretty cool. It's kind of like newer technology. I wouldn't call it bleeding edge. It's newer. Not a lot of people are using it. And it's something that we have supported for a major release now. We just released 2021. So we've got a major release under our belt with support for this. And I hope that people find it useful and start to use it. Again, I pointed you to this website here. Robert will provide these slides for you so you have all this information. But I provided a link here to our official documentation for Docker support, both traditional and this SSR rendering. And then we also provide you on we have a Bitbucket here that we provide you these files. So you can start with these Docker files. You don't have to build your own, but you can take these and modify them as you see fit. And then you can also reach out to your partner development manager. You can reach out to your consulting engineer, or you can reach out to me. You can email me directly if you've got questions. And then last, I've left a few links in here that I think if you're interested in this technology, you should do some further reading. And this is the NVIDIA Container Toolkit, what EGL is, and then where you can find the base NVIDIA containers for doing this type of cool stuff. And so now I want to leave time for questions here.
Can you start 2 containers at once?
Yeah. Well, yeah, so that's just it. Okay, with this setup right here, I can't because my image was specified to only listen on a single port. So if I try to start them twice, I'm going to get a port binding issue. But in production, you wouldn't set it up that way. You would not specify the port to open in your image. You would specify that on the command line of your Docker run command. So you would have some kind of in your application a counter of ports that you're using, and you would map that port at runtime when you run the container, and then you would pass that option into the container, which would go through to this SSR entry point, and instead of being specified right here, it would be specified as part of this runtime, as part of this guy right here. So the answer is in production, absolutely. And that, in fact, that's the way this is designed to be built, is to run multiple Docker containers. Okay, other questions?
And this is, I guess, kind of along the same lines, but how many simultaneous connections can one container handle?
Well, the containers are made, you want, the way that you want to build this is you want each container to specify, to handle one connection. But and because that provides you simplicity, it sandboxes all the data, so you're getting the fact that depending on how you set this up, you may segregate off if you're in a multi-tenant environment, you're going to segregate off your different tenant files, and one Docker container might only have access to one tenant's files. And so by design, you want one connection per container, and then you spin up as many containers as users come to your website.
Got it. Thanks, Rob. And we have one more question coming in from Matt. So is the model for scaling one running instance per client? If you opened up the server in 2 tabs, would rotating effectively change both tabs?
No. So you're saying if I try, yeah, what would happen is I wouldn't be able to open this model in two tabs, because that would mean 2 WebSocket connections, and those have to be on separate ports. So I couldn't open this in 2 tabs. And the model is to be 1 tenant per Docker instance. Yes. And so the answer to would it rotate both is no, because you couldn't connect two of these connect-to-streamers to the same instance. And I saw someone's hand was raised, another hand. I'm trying to get to the chat window, but it's kind of hard. And here we go. Did someone else raise her? So how would we redirect one user to one Docker and one? So that would be in your application level logic. So you'd have some kind of load balancer or some kind of front end that handles connections. Your user comes in, they log in, they're authenticated, and then that user needs to start up a connection. You have the logic on the back end that goes and starts up a Docker container. As it starts up, it provides to you its IP and whatever port you decided to open for it, because you're keeping track of those ports. And then that user is then connected to that WebSocket instance. So EGL has nothing to do with the containers. The EGL is just the interface by which we are rendering into a headless server. So let's think about if I were to just have, I could have showed you today, I could have just showed this title, this could have been headless rendering and using headless server-side rendering using Communicator. And what I could have demonstrated to you today was, let's start this streaming cache server on my physical Linux machine and render without installing an X server or without installing a virtual frame buffer or without using my UI system that's on this Ubuntu desktop environment. And so EGL is just a mechanism to render, to have a rendering context in memory, basically. And so, yes, it can run in an unlimited number of containers. The limiting factor of your containers is going to be the hardware that you're running on. So think about what you're going to be able to do now is you're going to be able to say you have, if you have container services that have GPU access, then the limiting factor would be the same thing that limits your standard Docker instances. It's going to be resource constraints at that point. Can I run these Linux containers on a Windows host? No. The NVIDIA Toolkit is not, you can run our traditional standard containers on a Windows host, but you can't run server-side rendering on a Windows host, and that's primarily because the NVIDIA Toolkit is only implemented on Linux. And there are a number of Linux variants, and also like Amazon Linux is supported and things like that. I think if you go to the NVIDIA Toolkit container, it tells you the platforms that they support. However, it's all Linux based. Great. Is there a limit of triangles geometry that containers can render? Yeah, it depends on the hardware. It's the same limitations as you're going to have running in a standard, on a standard server, which is, you know, memory and GPU and internet latency and the complexity of the models and things like that. Oh, I'm glad you liked it, Emmanuel. I was pretty excited about this. I started a few years ago with the Communicator team when I first found out about EGL, and I started playing around with it. And then I saw the container toolkit, and I couldn't get it working, and I played around with it. And then, you know, our development team was super responsive. They got me a build pretty quickly. I started playing with it, and yeah, so I just think it's pretty cool. And it's something that people have been asking since we started doing, since we released Communicator and server-side rendering. People have wanted to know how can they do it in Docker and how can they put it into their traditional workflows, and I think this is pretty good. Is there configurable automatic UI backend scaling management, or is it static sized frame buffer? Yeah, so I don't think that it's configurable the way that the backend works and generates the images for server-side rendering. I am a manager now, so I don't code day to day. So I'll have to go back and look I'll answer that question offline. I'll make sure to follow up because I want to make sure I haven't missed something in one of our later releases here, but I don't believe that the way the images and stuff are generated on the backend is configurable. Okay. We do releases. I think we do about 4 releases a year. So it's it's 2 major releases and 2 service packs. And then we do, kind of releases between that as needed. So you'll see hot fixes and stuff like that as needed. But generally, like major features like this are going to be released only in major releases. Major features like this, sorry. Yeah, Emmanuel, I think you will find that Communicator has progressed a lot. We've made some really great changes to it. We continue to develop it, as you can see here, and we do try to stay up on technology. So, this is something we found a year or 2 back, and we jumped on it and started planning to support it. I hope everybody enjoyed it. Again, if you've got questions, send them to me or Robert Beyer, or reach out to one of your contacts at TechSoft and we can follow up with you.